Hi all. We are in this video we are going to discuss about internal combustion engines. Internal combustion engines were used way back in earlier stages. So they started using solid fuels, liquid fuels, and gaseous fuel. They have tried a different set of fuels. Then they came up with proper fuels after numerous testings and other processes. So any device which is converting heat energy into work energy, that is called as a heat engine. So in this video we are going to discuss about different components of a IC engines. IC mean internal combustion. EC stands for external combustion engines. So internal combustion engines are so compact. We can easily carry from one place to another place. That is the purpose of or advantage of IC engines. All the two-wheelers and four-wheelers were propelled by IC engines. Nowadays, EVs were coming up in a recent time, but majority of automotive sector were ruled by IC engine. The reason for evolution of EVs are economy is one condition. Another main important factor is environmental consideration. So environmental consideration is the main reason for the evolution of EVs, but still majority of the market were ruled by IC engines only. So in this whole video for 30 minutes we are going to discuss about basics of an IC engine, like how it works, what are the different classification of engine, and different strokes of an engine, how we can improve the performance of the engine. Everything can be discussed in detail. So I have discussed many components in this system. Especially I will discuss about from basic to advanced technologies in IC engine, like a CRDI, common rail direct injection, and gasoline direct injection, and those things will be discussed in this video. Yeah. So if you have any doubts and other things, you can discuss it, or you can post your comments. You can post your doubts in comment section. So I'm happy to share or clarify your doubts. Okay. So let's get into the lecture.
In thermal engineering 1, in unit number 1, we have discussed about air standard cycles. In unit number 2, we have discussed about air compressor. In unit number 3, we are going to discuss about internal combustion engines and combustion in internal combustion engines. So let us get into the subject. So generally, heat engines means any device that is converting heat energy into work energy, that is termed as a heat engine. So and we have two broad classification in heat engines. One is external combustion heat engines, another one is internal combustion heat engines. External combustion heat engines were not in use, almost phased out from industrial use. Nowadays we will use, most of the time we will use internal combustion engines. The reason is external combustion engines requires larger space and losses are more, and it needs much larger space also. So for that reason we will not use external combustion engines. On the other hand, internal combustion engines will need lesser space and it will be efficient one compared to external combustion engine. Internal combustion engines were efficient. That's why we will use internal combustion engines most of the time. So in this unit we are going to discuss about internal combustion engines. Internal combustion, again first you should know the difference between internal combustion engine. If combustion and expansion takes place in the same location, that is termed as an internal combustion engine. External combustion engine means combustion will takes place in one device, expansion will takes place in another device. If you take an example of power plant, combustion will be takes place in a boiler. Inside the boiler you will have a grate, over the grate the coal is filled, the coal is burnt inside the combustion chamber that is placed in a boiler. Combustion chamber will be available inside the boiler. You will burn the coal, that coal will liberate the heat. Over the walls of the boiler you will have water tubes. Those water tubes will absorb the heat, and heat is being liberated inside the boiler. That heat is absorbed by water, then water will be converted into steam. That steam is routed to turbine to produce mechanical work as an output. This is how external combustion engine will work. Combustion will takes place in a boiler, expansion will takes place in a turbine with the help of a steam. If you take two-stroke or four-stroke petrol engine, combustion also takes place inside a cylinder, expansion also takes place inside a cylinder. Both are takes place in a single location. That's why it is termed as an internal combustion engines. So let us get into the nomenclature of internal combustion engines. Here in this device I have shown a cut sectional view of IC engine. It is not a SI or it is not a CI. It is a cut sectional view of IC engine. You will find most of the components in both the engines, SI or CI. You can find inlet manifold. The purpose of inlet manifold is to admit atmospheric air into the cylinder. It differs. In case of olden day SI engine, it will admit both air and fuel. Nowadays you will have a fuel injection technology in SI engine also. So during suction stroke itself you can take or you can send both air and fuel into the cylinder. Okay, then you will have an inlet valve. The purpose of inlet valve is to send air fuel mixture into the cylinder. That is the purpose of inlet valve. Then exhaust valve is to send burnt gases to the atmosphere. That is the purpose of exhaust valve. Then you will have a exhaust manifold. It is a passage that is connecting exhaust valve to the atmosphere, that is exhaust manifold. Then you will have a cooling medium. Again two types of cooling will be there in IC engines. One is air cooling, another one is liquid cooling. Why I am using it as a liquid cooling means in that liquid might be anything: water, ethylene glycols, any substance which is useful, which is used in a cooling system. The thing is, it has to absorb the heat in a faster rate, at a faster rate. That is the main requirement of coolant used in a cooling medium. Then we have a piston. Piston is made up of aluminum silicon alloy, which is moving between two dead center. That is top dead center and bottom dead center. We will discuss what is mean by top dead center, what do you mean by bottom dead center in upcoming sections. Then you will have a crankshaft, which is which is connected to the rear wheel of vehicles. Because rear wheels, most of the time, if you take bikes, some other vehicles, most of the time power is supplied to the rear wheels. So those, if you take two-wheelers, rear wheels are connected with the engines through chain drive. So you will have a crankshaft is connected to rear wheels. Then connecting rod, the purpose of connecting rod is it is used to connect crankshaft and piston. Again, connecting rod will have two ends, bigger end and smaller end of the connecting rod. Bigger end of the connecting rod is connected to the crankshaft, smaller end of the connecting rod is connected to the piston. Again, smaller end of the connecting rod is connected to the piston with the help of piston pin. The purpose of, again, at the end of the piston pins you will have a circlip to have a better hold in a piston. At the bottom you will have a crankcase. Most of the time in a crankcase lubrication oil will be stored. we will store lubrication oil at the bottom of engine. That component is termed as a crankcase. Then we will have a cylinder that is from this portion. This is termed as a cylinder. Here air fuel mixture will be filled inside the cylinder. Sometimes air fuel mixture during suction stroke itself, sometimes only air during suction stroke. We will discuss when air will be filled, when air and fuel mixture will be filled in the upcoming sections. So this is all about basic components in IC engines. Then these are all some basic nomenclature. Before getting into what do you mean by dead center, we should know what do you mean by top dead center and bottom dead center. We should know what do you mean by dead center. Dead center means the location at which piston changes its direction of movement. That is called as dead center. If it is changing its location at the top, that is termed as top dead center. If it is changing its location its direction at the bottom, that is termed as a bottom dead center. So again here we have inner dead center, outer dead center. When we will use inner dead center and outer dead center means, if the cylinder orientation is horizontal, instead of using top dead center and bottom dead center, we will use inner dead center and outer dead center. If the cylinder orientation is vertical, we will use top dead center and bottom dead center. Most of the time the cylinder orientation will be vertical. That's why we will use frequently we will use TDC and BDC. Then stroke length means, stroke is otherwise termed as stroke length. Stroke length is nothing but the distance between TDC and BDC. That is termed as a stroke length or stroke. Bore is nothing but a diameter of the cylinder. The diameter of the cylinder or diameter of the piston. There will be a slight difference between diameter of the cylinder and diameter of the piston. Then clearance volume means, clearance volume is otherwise termed as a minimum volume that prevails in a cylinder. Or when the piston is at the top dead center, the volume occupied by gases inside the cylinder, that is termed as a clearance volume. Cylinder volume means it is summation of maximum volume or summation of clearance volume and stroke volume. Both the ways we can tell cylinder volume. Cylinder volume means that is a maximum volume that gases or charge can occupy inside a cylinder, that is termed as a cylinder volume. Stroke volume means the volume occupied between top dead center and bottom dead center, that is termed as a stroke volume. Again, based on a stroke and bore of an engine, we can classify the engine into three parts. If the stroke and bore is equal, that is termed as a square engine. If stroke is larger than bore, that is termed as a under square engine. If bore is larger than stroke, that is termed as a over square engine. Again, under square engine will be utilized in low speed engines. Over square engines will be utilized in high speed purpose. Again, then next term will be compression ratio. Compression ratio is nothing but it is the ratio between total volume of the cylinder and clearance volume. Total volume means maximum volume occupied inside the cylinder, divided by clearance volume is nothing but minimum volume that can prevail inside a cylinder. So the ratio between maximum volume and minimum volume, or total volume divided by clearance volume. Both ways are given in a textbook. That depends on a author. Both are correct. Then cubic capacity means sometimes cubic capacity most of the time will be mentioned as cc. That is in advertisement or in vehicles 150 cc, 180 cc, some numeric numbers will be given along with the cc. That cc is nothing but swept volume or stroke volume. So the stroke volume is mentioned in a specification. So this is basic nomenclature in IC engines. These are all some basic components. This here in previous slides we have seen those basic components that here we have listed out. Again, IC engines were classified based on different parameter. First one is based on working cycle. Again, whether it is a 2-stroke cycle or 4-stroke cycle. Based on working cycles, we can classify the engine. Based on method of ignition, we can classify whether it is a spark ignited engine or compression ignited engine. Based on fuel used, whether it is a petroleum based engines, diesel engines, gas engines. Based on fuel used, we can classify engine into 3 types. Then based on application, whether the engine is stationary, portable engine, whether that engine is used in automobiles, marine or aerospace applications. Based on the application, we can classify. Again, based on the cylinder arrangement, whether the cylinder is arranged vertically, horizontally, radially. Sometimes we'll have V engines. So these are all some arrangements, classification based on arrangements of cylinder. Then based on the speed, slow speed engine, high speed engine and medium speed engine. Based on the number of cylinders, single cylinder engine and multi-cylinder engine. Based on method of cooling, water cooled engines or air cooled engines. Most of the time we will not use water cooled engine. We will term it as a liquid cooled engines. In olden days, they have used water as a coolant. That's why here they have mentioned it as a water cooled engine. Nowadays we are using ethylene glycol as a coolant. The reason is at atmospheric condition, water will turn into ice at 0 degree centigrade. To avoid that problem, we will use ethylene glycol as a coolant in water cooled engines. In IC engines. So let us discuss working of 4-stroke SI engine. Then let us discuss 4-stroke CI engine. 4-stroke, in previous sections I have told stroke means the distance between top dead center and bottom dead center. If it is a vertical cylinder engine, if it is a horizontal cylinder engine, the distance between inner dead center and outer dead center. Here the cylinder is vertical, so we will use TDC and BDC while discussing the each and every stroke. So 4-stroke means the piston has to travel from 2 dead centers 4 times. So this is linear. Here we will have a rotary. If you are expressing with respect to crank rotation, the crank has to rotate twice because 1 stroke is equal to 180 degrees crank angle. So 360 degree crank angle is 1 revolution. Here we will have 4 strokes. So the crank has to rotate 2 times. If the crank is rotating 2 times, it is completing 1 cycle. Or other words, if the engine is completing 4 strokes, that is constitute to 1 cycle in 4-stroke engine. So again, here we will have a inlet valve, exhaust valve, spark plug, then piston, connecting rod, crank. This is simpler line diagram. So during suction stroke, what you notice is inlet valve alone kept in an open condition and exhaust valve in a closed condition. During suction stroke in SI engine, in olden days, both air and fuel will be entered into the cylinder. air and fuel will be mixed with the help of carburetor. That air and fuel mixture will enter into the cylinder during suction stroke itself. But nowadays we will have fuel injection technology in a SI engine, that is gasoline direct injection. So we can inject fuel at the end of the compression stroke also. For discussion sake, now understand we will discuss with respect to conventional SI engine. Okay, then during suction stroke, air and fuel will enter into the cylinder. Only inlet valve will be in open condition. The piston movement direction is from TDC to VDC. When the piston is moving from TDC to PDC, the pressure inside the cylinder is drops lesser than atmospheric pressure, then only suction will take place. This inlet manifold is connected to carburetor. Carburetor has two ends. One end is connected to inlet manifold, another end is connected to air filter. Air filter is exposed to atmospheric pressure. So lesser pressure on one end of the carburetor, higher pressure on one end of the carburetor. So we know from our understanding, air will move from higher pressure to lower pressure. So air is moving from atmospheric to engine cylinder. That is all about suction stroke. When the piston is reaching bottom dead center, the cylinder is full of air and fuel mixture. Then after it is reaching bottom dead center, it is reversing its direction of movement, and it is started to compress the air fuel mixture inside the cylinder. That is from bottom dead center to top dead center, compression stroke. During compression stroke, the pressure of the air fuel mixture is increasing, so the gases will tend to move out of the cylinder if any one of the valve is kept in an open condition. With the help of valve mechanism, we will close both inlet valve and exhaust valve for effective compression of air fuel mixture. During compression stroke, both air and inlet valve and exhaust valve is in a closed condition. Both the air fuel mixture is getting compressed. So during suction stroke and compression stroke, the pressure and temperature is rising inside a cylinder. If because of this reason, both air and fuel is getting mixed together well inside the cylinder. So that's why air fuel mixture inside the SI engine is termed as a homogeneous air fuel mixture. So then after it is reaching top dead center, the spark will be produced with the help of the spark plug. Spark plug is producing a spark that is initiating a combustion. Because it is a homogeneous mixture, gradually the flame front is moving from TDC to BDC. Because of this combustion, gases will tend to expand. The piston is experiencing that gas force, and these gases will pushes the piston from TDC to PDC. Again, if any one of the valve is kept in an open condition during expansion stroke, we will lose some amount of energy. For that reason, with the help of valve mechanism, both inlet valve and exhaust valve is kept in a closed condition. Again, the piston movement is from TDC to BDC. Then once it is reaching bottom dead center, the burned gases should be expelled out of the cylinder. For that reason, the exhaust valve is kept open during exhaust stroke, and the burned gases will move out of the cylinder. So this process is termed as a scavenging, the process of expelling burned gases from engine cylinder to atmosphere, that is termed as a scavenging. Here the main thing is the spark is produced at the end of compression stroke, and during compression and expansion stroke, both the valves kept in a closed condition. We will use spark to produce combustion inside a cylinder. We are using external source spark plug to produce a combustion inside a cylinder. Then in first unit we have discussed about air standard cycle. Auto cycle is the ideal cycle for SI engine. So this is nothing but auto cycle that you have discussed in a first unit. Two constant pressure process and two isentropic process, that is combination of processes in auto cycle. So this is ideal auto cycle. This is actual auto cycle. If you are using pressure transducer and indicator diagrams, you will get this type of valve. The shaded portion is indicating the pumping losses in system. Pumping losses mean during suction stroke and expansion stroke we will spend some amount of work. That work is termed as a pumping losses. The shaded portion is pumping loss in working system. Again, the working is 4-stroke. This is working of 4-stroke CI engine. Only thing is, during suction stroke, only air will enter into the cylinder, not the combination of air and fuel mixture. That is possible only in SI engine. In case of diesel engine, only atmospheric air enters into the cylinder during suction stroke. Inlet valve is kept in an open condition. Piston will move from TDC to BDC. Then during compression stroke, the air is compressed to a very higher pressure and temperature. If you are increasing the pressure, automatically temperature also will increase. So the temperature should be in such a way that at the end of the compression, the temperature of air should be higher than auto ignition temperature of diesel, because here we don't have any external ignition source like spark plug. The fuel has to ignite on its own with the help of temperature available in air. For that reason, the air is compressed to a very higher pressure and temperature inside a cylinder, and fuel will be injected at the end of the compression stroke. Again, during compression stroke, both inlet valve and exhaust valve is kept closed for effective compression. Once it is getting compressed to a very higher pressure and temperature, the fuel will be introduced inside a cylinder. Here we will give only lesser amount of time for air and fuel mixture time. Air and fuel mixing time is very smaller. That's why air fuel mixture in diesel engine is termed as a heterogeneous air fuel mixture. So heterogeneous air fuel mixture is used in a CI engine. Homogeneous air fuel mixture is used in a SI engine. Then once the combustion is initiated in one location, heat will be transferred to remaining part of the cylinder by radiation and convection heat transfer mechanism. So because of radiation and convection heat transfer mechanism, combustion will occur in a different location of a cylinder, just like exploding bomb in a different locations. So but in case of combustion in SI engine, it is just like burning a piece of paper from one end to another end. So that is gradual. Here the combustion is erratic. That's why compared to SI engine, CI engine will produce more noise, because the combustion is relying on auto ignition of air fuel mixture. During expansion stroke or combustion stroke also, both inlet valve and exhaust valve is kept in a closed condition. Then again during exhaust stroke, only exhaust valve is kept in a closed condition. The burned gases will be sent out of the cylinder. So this is all about. Then this is all about 4-stroke CI engine. Then SI engine means spark ignition. That is called as SI. Shortly we can tell it as a SI. SI engine is nothing but petrol engine. Compression ignition engine, because the compression ignition engine is otherwise termed as a diesel engine. Why it is termed as a compression ignition means, here we will initiate the combustion by compressing air from lower pressure to higher pressure. That's why it is termed as a compression ignition engine. Okay. Then the ideal cycle for compression ignition engine is, that is CI engine is diesel cycle. Then diesel cycle is a combination of one constant pressure process, one constant volume process, and two isentropic process. Again here also you will, this is ideal cycle for CI engine. This is actual cycle, that is in the actual indicator diagram that is obtained from CI engine. So this is all about today's class. We will discuss remaining sections in upcoming classes.